Look at this table. It may look like a wall of random letters and numbers, but this table is actually a map of all the elements, chemical elements we know. And here is an interesting part. Once you understand how this table is organized, you can predict a lot about an element without memorizing everything about it. This is the periodic table of elements. So let's understand how it works. What is element? Before we understand this table, we need to understand one word, and that is an element. An element is a pure substance made of only one type of atoms. Only one type of atoms. For example, this is hydrogen, and this is oxygen, and this is carbon. They are different elements because their atoms contain different number of protons, and scientists have arranged these elements into one organized table, the periodic table. Atomic number. Atomic number is the number of protons. That means suppose hydrogen has atomic number of 1. That means every hydrogen atom has only one proton. Carbon has atomic number 6. That means every carbon atom has 6 protons. And oxygen has atomic number 6. That means, 8. And that means the number of protons are 8. So this number is extremely important because the number of protons determine which element the atom is. Here is a simple question. That if I somehow changed the number of protons in an atom, would it still be the same element? No. Changing the number of protons and you have created a different element. For suppose if you add one more proton into hydrogen, that means 2 protons, then it becomes helium. It doesn't remain hydrogen atom. So now let's look at the horizontal rows like this. As we move from left to right across a period, the atomic number generally increases by 1. So these horizontal rows are called period, and periodic table has total 7 periods. So hydrogen is number 1, helium is number 2, and the lithium is number 3. And so on. But periods are not just line separating elements. They tell us about the electron shell of atoms. Elements in the same period have the same number of shells. So same period, that means the same period will have same number of shells. And these vertical columns are called groups. There are 18 groups in the periodic table, and here is something very useful. Elements in the same group often have similar chemical properties because they have similar valence electron arrangement. So in a group, they will have similar chemical properties. For example, element in group 1 are called alkali metals. And now look at this group, 17. This group, they are called halogens. So the 17 groups are called halogens because of the same chemical properties, and they are also very reactive. Another useful way to read the periodic table is by dividing elements into 3 broad categories: metals, non-metals, and metalloids. Most elements are metals. They are generally shiny, malleable. They are good conductors of heat and electricity. For example, it includes iron, copper, and aluminium. These are all metals. They have generally different properties. And so in the next class is non-metals. They have different properties as compared to the metals. For example, it includes oxygen, nitrogen, and sulfur. And between metals and non-metals are the metalloids. And they have properties that are intermediate between metals and non-metals. So metalloids example is silicon. That is most famous one. Now let's connect this to something we learned in atomic structure. Atoms contain electrons, and electrons are arranged in around the nucleus in energy levels, or we can say them as shells. So electrons in the outermost occupied shell are called valence electrons. So the last shell contains the electrons and are called valence electrons. These electrons are extremely important because they have played a major role in chemical bonding and reactions. That's the one reason elements in the same group often behave similarly. Now imagine chemistry without the periodic table. You would have to memorize the properties of every element separately. But the periodic table gives us a pattern. From an element position, we can learn things about it. Its atomic number, electron arrangement, group, period, and general chemical behavior. So the periodic table isn't just a chart to memorize, it is a tool for predicting chemical behavior. One thing that often confuses a student is these two rows. These two rows are called lanthanides and actinides. They are actually part of the main periodic table, but they are usually placed below it to keep the table more compact. The actinide series includes elements such as uranium and actinium and so on. So let's quickly review. Atomic number tells us the number of protons. Groups are the vertical columns, periods are the horizontal rows, and the elements in the same group have similar chemical properties. Now here is your challenge. Find an element on the periodic table and tell me its atomic number and group in the comment. And if you want chemistry explained without complicated language, subscribe for the next lesson. I will see you in the next one. Thank you.